This video is about problem 6.20 from the practice test. All right, so this problem says a wind turbine has a 12,000 kilogram blade. Each blade is 12,000 kilograms, and the blades spin at 22,000 RPM. Um, so let's do this problem real quick. um, because this is a good problem, and let's talk about how to solve this problem. All right, so let's draw a picture of our blade here. These are um, 12,000 kilograms. Okay, so that's going to give us a our mass, and then the problem says um, if we model a blade as a point of mass at the midpoint of the blade, what is the inward force necessary to provide each blade's centripetal acceleration? All right, and let's write down the speed here. The revolutions per minute are um, 22,000. Okay, so that's RPM. So we'll say revolutions per minute. And the length is 35 meters. And this is going to be, we're going to model it as all of the point is in the middle of the blade right there. Okay. And so we're going to find the centripetal um, acceleration. And it says, what is the inward force necessary? Okay. So the equation we're going to use for this is F equals ma, so Newton's second law, but the acceleration is going to be centripetal acceleration. So AC is going to equal V squared over R. Okay. And since all of our mass is located here at the center, what we're going to use for this is we're going to say um, L is going to equal 35 meters divided by 2. Okay. Because that's at the middle of the blade. Okay. So let's see. So 35 divided by 2 is 17.5, which I knew that. 17.5 meters. Okay, now all we need to do is we can plug it into this formula, but we need to know what V is. We don't know what V is. We know how fast it's spinning, but we need to know what V is here. So if something's rotating in a circle, okay, then we're going to use the formula for uh we're basically going to say, all right, what is the circumference of my circle? Okay, so that's 2 pi r, and then we're going to divide that by the period t, and this is going to give us what v is. Okay? Because this is basically the total distance that this point is going to travel, and we're going to divide it by our time here. Okay? And the period is how long does it take to complete one revolution? Okay, well, up here, we know that it does 22 revolutions per minute. So we need to find that in seconds. Okay, and this is our period. If we do everything correctly, it should come out in seconds. Actually, this is our frequency. Okay, so we need to get this um, into period. All right. So first thing we're going to do is we're going to convert this into seconds. So it's going to be revolutions per second. So it'll be 1 minute divided by 60 seconds. Okay. So we're going to have, I'm going to multiply this here. So it'll be 22 divided by 60 seconds. Okay. So I'm going to just use my phone for this because it's real quick. So 22 divided by 60. is that's going to give us a frequency of 0.3667 per second. And I know this is frequency because it's 1/seconds. Okay. Now, down here, right, remember the formula that we had is frequency equals 1/period. So we can change this. We can instead we can rewrite this and we can say 2 pi r times f, which is what we calculated up here. That is our frequency. Okay, so our frequency is this. Um, but now I'm gonna plug this into my formula up here. Okay, so I'm gonna substitute this in right there, and then okay, we're gonna rewrite our formula here with everything. Okay, so this is gonna be two or all right, so we're gonna plug this into our formula here. So this will be 4 squared times pi squared. And then we're going to have uh, an r squared up here. Okay. And we'll also have um, our frequency squared as well. And then this is all going to be divided by r. Okay. And so our r's here are going to cancel. Okay. And so now I'm going to plug this end over here. I'm going to write out the full thing. Okay, so our frequency then, or no, sorry, our force is going to equal mass of the blade times the acceleration. So we'll have 4 pi squared. Um, then we'll have an r up here and our frequency squared. Okay, and then let me make sure I'm not forgetting anything because this is usually the part where I forget to write something. Okay, this looks like our whole formula here. Okay, so we're just going to plug in the numbers. We're going to have 12,000 times 4 pi squared times r. And r is the length of this. So we said that that was 17.5 meters. 17.5 meters times the frequency, which we calculated up here. This will be 0.3667 squared. And let me plug all this in real quick. 12,000. All right, I'm going to put this in times 4 times 3.14159. That's pi to 4 digits. That's going to be squared. So that will be, get a squared there, times 17.5 times 0.366667. And that's also going to be squared. Okay, and we're going to get that the answer is going to be 1 point, yeah, 114 times 10 to the 6 newtons. Let's put that in real quick and see what we get. So 1 uh went 1 times 10 to 6, and that's newtons. Right. And that is the correct answer. Okay. So the answer is 1.14, or what I entered was 1.1 times 10 to the 6 newtons. All right. Thanks for watching this video.
Thank you, like and subscribe down below.